Ladies and gentlemen, the floor is yours. What questions do you have? 5-3, 5-4, 5-5.
You have to distribute it. Does it become a minus C or just a main plus?
It doesn't really matter because if you change, say I'm going to change it to -2, I could make it plus -2, couldn't I? But since I don't know what the value of the constant is, it really doesn't matter whether it's plus or a minus in front of it. Yeah, absolutely. As long as you got a constant there, the sign on it is irrelevant when it's in the general form. When it's in the specific form, I need the constant to be correct. But that means as you solve for that constant, you have to keep track of what you distributed and what you didn't. Yes, ma'am. 5, 3, 16. So 15 or 17, pick one. So 5, 3, number 17. Asks us to find the derivative of 1 to 3x plus 2, 1 over 1 plus t cubed dt. Why, yes, it is. Now, since the goal is to find the derivative, I'm going to apply the fundamental theorem of calculus that says that when I do the derivative to a definite integral, as long as the bottom is a constant, I simply take the top thing and plug it in. But that applies when the top thing is an x. The top thing here is not an x. If that was the derivative with respect to 3x plus 2, I'd be done. But I'm doing my derivative with respect to x because that's what this y prime means. It means the derivative in terms of x, which means I'm really doing a chain rule problem. I need to think of this as if it was the inside function, because I'm taking the derivative with respect to x, and that's not just an x. Chain rule tells me to do what? Multiply by the derivative of that piece. That's it. That's all I need to do. Exactly. I do it every time. I do the chain rule every time, but dx is just a 1. The chain rule is inherently built in to all of the derivatives. We just didn't think of them in that way because I'm multiplying by 1, big deal. More questions? Yes, Ed. 5.48. 5.548. Yes, okay. That problem, Evan? Okay. One of the things I don't like in most of writings in fractions like this is that I can't always see the pieces separately enough. So I tend to rewrite things like this. to separate the numerator and the denominator. It's not always required, but my first reaction was, what's the inside piece for my chain rule, my use substitution here? It's that logarithm, right? And if I use that as my inside piece, then the derivative is 1 over t. So by separating it, I can see that u and du show up more clearly. And then I rewrite my equation in terms of u. And what's something whose derivative is cosine? Sine of u plus c, but I started in t, so I'll finish in t. There we go. My goal is always to find the relationship between my inside function and its derivative somewhere in my integrand in the first place. Better? Wonderful. More questions? Yes. So the 1 over t and the dt together got subsumed into here. So this piece is replaced by this one in my new variable. When you integrate, your differential goes away and your plus c shows up. More questions? Five, four, number 11. The integral of 5 plus 2/3 x squared and 3/4 x cubed dx. Okay. I'm just asked what's the integral of this, so I'm really just doing the general antiderivative. I have a 5. What's 5 the derivative of? I can also think of this 5 as having no x's on it at the moment. Right? Well, now I think of it as a power rule. So when I want to get the antiderivative power, I add 1 to the power and I divide by the new power. So that just gets an x. Same thing here. The 2/3 stays. X, add 1 to the power, divide by the new power. The 3/4 stays. Add 1 to the power, divide by the new power. But wait, there's more. I got to put a plus c on the end of this. And now it's up to you as to whether or not you want to simplify the multiplication of all of these numbers together. Multiply the denominators, 3 times 3, 4 times 4. That's not required, but it certainly makes the answer look nicer. That's it. It just said Find the general indefinite integral. An indefinite integral is just another name for the antiderivative. But since I'm looking for the general one, I'm going to leave that plus c. It isn't until I get a little further on where I start to say, oh, well, let's have a value and try and solve for that c. That's not actually in this section, that's in the next one. No, in the previous one. More questions? Yes. Oh, our symmetry theorems. Yes, you can only do the symmetry integrals when you're integrating from minus thing to the same thing. -3 to 3, minus pi to pi, -1 to 1. If you're going from -1 to 2, you can't do that. You can't use those theorems.
Whether trig functions are even or not.
Well, you can do it in two different ways. We can actually go back and plug things in. So you could do it simply by graphing. What's the graph of cosine of x look like? Let's be a little more specific about the graph. If I think of starting from the middle at x equals 0, that starts with cosine of 0 equals cosine of 0 is 1, and then we get a graph that looks like this, right? What does it look like on the left? The same thing. Hey, wait a minute. That means that if I pick a value over here, and I pick the same value over there, that f of negative x is equal to f of x, this function is even. What about sine? Because sine of 0 is 0, and the graph goes up and then down on the right. But if I start from the center, oh, f of minus x is the opposite of f of x. This function is odd. So I can do it literally by looking at the symmetry left to right. When they're even, they're a book. Everything on the left is exactly the same as what's on the right. When they're odd, it's that diagonal symmetry that goes through the origin. Everything that's up on the right has to be down on the left. Everything that's down on the right has to be up on the left. The rules now work for multiplying odds and evens. If you take an even thing times an odd thing, what do you get? Even times odd, 2 times 5. I think numbers should be even, right? But sine of x times cosine of x. If I put in a negative x, I'm going to get sine of minus x times cosine of minus x. Cosine is even. But sine is odd. So this function, when I put in a minus x, I get minus times the original function. This function is odd. So once I know how to do sine and cosine, I know how to do tangent, secant, cosecant, cotangent. And then I know how to do things when I multiply them by x's or other functions in general. Does that help? Powers of x follow their exponents when they're integers. Fractions, you can't tell whether fractions are even or odd, right? You need to then look at more things. More questions?
Yes, manipulating the traits is something like 46, but there's a condition in the numerator.
46 from which section? 5.4. I'm going to suggest that when we see things that are sums or differences of trig functions, I'm going to have to go back and pull up some trig identities. So I'm going to try and simplify that as much as possible before I do any work. And that may mean that you need Appendix D, where all of our trig identities were, or the formula sheet that's on our Canvas page, long trig identities list. But I only really remember 3 trig identities. I only have memorized 3 of them. Everything else I get from those. Pythagoras. Sine squared plus cosine squared is 1. Right? That's my Pythagorean identity. There are other versions of this. There's one involving tangents and secants. There's one involving cotangents and cosecants. What's tangent? Tangent's sine over cosine, right? Divide everything by cosine, and this becomes a tangent. This becomes a 1. This becomes a secant. I don't have to memorize that one. I can get it from the first one. If I divide by cosine instead, if I divide by sine instead, so I divide by sine squared and cosine squared in both cases. So I only need the first one, and I can get the other 2. I remember sine of 2x is 2 sine x cosine x. And I remember that cosine of 2x is cosine squared x minus sine squared x. And there are 2 other versions of that as well. But you can build those using Pythagoras. If you want to get rid of the cosine squared, you rearrange this. If you want to get rid of the sine squared, you rearrange this. Literally, those are the only ones I remember. Everything else I can kind of work my way through algebraically. The list is gargantuan. I don't want you to memorize all this. I want you to know a couple of them, and then the techniques for getting the others are just algebra. But yes, when I see something with all mishmashed of trig functions in it, I'm going to go here. And I'm going to say, what can I use out of this pile that's going to make my life easier before I integrate? Integration is hard. In order to do it properly, I'm going to have to do algebra either before or after to make my life easier, just with derivatives, right? I either have to do all this algebra before I take my derivative, or I have to do it all afterwards to find the critical numbers. I have to do all this stuff before, so I get as simple a thing as I can get to do the antiderivative. Better? More questions? 5.5, number 19. Cosine cubed theta, sine theta. The most important thing to remember about an exponent on a trig function is it is really on the whole trig function. Remember, the letter is a complete red herring here. I don't care whether you use theta, t, x, z, it doesn't matter. Pick whatever letter you like if you don't like theta. But now I clearly see an inside versus an outside, don't I? I see thing cubed. There's my chain rule. That's my U substitution. The inside piece. What's the derivative of cosine of theta? I'm missing a minus sign. You have your choice here. Do you want to manipulate the differential here, or do you want to manipulate the integral up there? Okay, so I'm going to move the minus sign by multiplying on both sides by -1. Now this piece matches what's here. This piece matches what's here. And I get u cubed. And then I get a negative du, right? But the minus sign is a number. It's a -1. Where can I put it? Ta-da! What's the antiderivative of ugly thing cubed? But wait, there's more. Yep. And now put it back into theta because that's where I started. -1/4 cosine theta to the 4th. I can put it there, or I can put parentheses surrounding it. Your call, plus C. I think this is what you were asking about earlier, Emily, is that the minus sign is outside, right? But the plus C is taken care of after I do the antiderivative. So do I need to distribute that minus there? No, I really don't. But if I did, it'd still be okay.
That is actually boundary. Because definite bounds.
Oh,
How far down can you carry the C? Like, before we plug in the numbers, how many steps do you need to see, or do you kind of just before it cancels itself? Because if you know it's gonna cancel itself, how far do you have to show it?
in a definite integral, you never need to show it. If you are doing a definite integral, I need to do the antiderivative of x squared, right? The antiderivative of x squared is 1/3 x cubed. I know the c is going to cancel out right now. I don't need it.
But if you showed it the first step,
Then you're fine. As soon as you do the next step, you'll need the c's because you'll need the subtraction in between to show that they cancel. I need to show it once. I need to show from here to the plug-in. So if I were to write 1/3 8 minus 1/3 1, that's done as far as the one without the c. But if I write this, right? Then in the next step, I at least need to see that you didn't just throw them out. But now you've got a plus c and you've got a minus c. They're gone. So I need to see that you plugged in the numbers to your antiderivative. And if your antiderivative had a plus c on it, then here where you plug in, you should still have a plus c. At least at that first line. After that, well, clearly they're going to cancel. One's a plus, one's a minus, off they go. But if you leave them off at the very beginning, that's still good because you knew they were going to cancel all along. Make C be 0 and walk away. You're welcome. My afternoon class, I had this exact same discussion. Only that problem had 2 C's because we did 2 different things. More questions. in the scoring guidelines for the AP exam, I am told that I need to see an antiderivative. I need to see an evaluation of that antiderivative. So when I see you write this, if your next step was this, then you didn't evaluate your antiderivative. I didn't like that ruling when they showed it to me, but I understood why they meant it. But I get it.
Number 60 and 34 is it saying that I is the derivative of Q?
That's what's written there. It says I of t is q prime of t. Yeah. What's q again? What does it say? So q is the amount of charge in a wire. Okay, short physics diversion. Who took a physics class somewhere? Okay, charge is measured in number of electrons. The units suck because they're named after a person. All the units in electricity and magnetism are named after people. It's measured in Coulomb. But it's really number of electrons. The more electrons you have, the more negative charge you have. The lack of electrons gives you positive charge. But really, you're looking at buildup of electrons. Current is the number of electrons that move past a particular spot. Change in charge over time. I pick a spot in my wire and I count how many electrons go past. When 1 coulomb of electrons have gone past in 1 second, that's an amp. So when you go downstairs after your breaker blows and you see a box that says 15, that's a 15 amp line. It's measuring how much current is going through it. Again, named after person, ampere. Volt. Yeah, they're all named after people. At least in kinetics, the units make sense. Meters, square meters, coulombs, kilogram meters per second squared over square meters, pascals. No, don't name it after a person. Give me the regular units. Yes. Current is the derivative of charge. (5.5), number 25. ln of x quantity squared over x dx. I'm going to do the same thing for you that I did for Evan earlier, and I'm going to separate the numerator and the denominator. And again, I see clearly an inside and an outside. This step is technically unnecessary, but I find it much more clarifying to then be able to say, oh, here's an inside. What's the derivative of ln of x? It's 1 over x dx. There we go. Can you finish it out for me? Give it a try. The important thing to note here, this is why parentheses are important. If I write ln of the quantity x squared, I can take the square out. But when it's ln of x all squared, I can't take the power out. Power's not inside the logarithm to begin with. So as much as with sine of x or tangent of x, even when I just write ln of x, you'll notice I didn't put parentheses. It's the way it was written in the text. I got to be careful where I put exponents then. Because writing ln of x squared without any parentheses at all is the square on the x or is it on the whole thing? And they mean different things. So Haley, if I switch this to be into U, what's my new version? I don't know where the minus sign came from because here I get a U squared, I get a du. I didn't get a minus sign this time. So I'm going to get a positive U cubed over 3. And then I'll put it back into ln's. More questions? Y'all got this. Either that or you're completely spaced out and I can't tell which because it's early in the morning. For some people. I'm sure some people are going to tear their hair out like me. Well, then you have to go back and study trig more. Yeah, I'm terribly sorry for that. Oh. More questions, people. Ask me more things.
It's not just X. How do you know what you can take out and you can't, like, you always make it go into an X and exponent? Like, it was like.
No, I can only,
That can be even X tilde.
no. That only works for a logarithm, not for an e. It is 5 ln of x that becomes ln of x to the 5th. It only works on logarithms, not on exponentials. What we're thinking of is multiplying powers, right? I'm multiplying powers. So I could think of this as e to the x all to the 5th, but not e to the x to the 5th. Okay. Yeah, so it's important. Those are not the same. But when you are multiplying powers, that is the same as taking a power of a power. So yes, that is a true statement, but just not this version. Which is interesting because it means that when we read powers, we technically should be reading them from the outside in, not the inside out. Weird. More questions. Any more people? A puzzle question for you. Yep. Imagine that tower of x's is infinitely long. You can solve this problem. You don't need a limit. You don't need any fancy calculus. You can do this with nothing but algebra skills. Infinity's weird, man. Anyhow, Save that for later. More questions on antiderivatives? I got 15 more minutes with your names on it. You've already paid for it. I have no reason to nail your butts to chairs. If you don't have questions, you are free to leave today. I will see you all tomorrow. No, I will see you all. Yes, tomorrow. I know what day of the week it is, really. No, yeah, no. Am I getting this right? 5, 2, and 5, 12. Yeah, I think there are 14 days. I'll see you all later. Our final is scheduled for bright and early, I think. Yeah. When in doubt, check the schedule. Bunk. Wednesday the 10th, 8 a.m. I've had an 8 a.m. final every year. Don't feel bad. It used to be Friday at 8. We don't have any exams on Fridays anymore.
Minimize stress. Minimize stress.
No, my state is Liz thorough. Because it's always my later classes that end up with those earlier exams.